Hey there everyone. This video is going to focus on ratios and equivalent ratios. So here we go. So ratio is going to be a comparison between two numbers by division written in several different forms, which we will look at in a bit. So the order of the numbers in a ratio should match the way it appears in the word or phrase or the problem, whatever the case may be. If I was going to compare apples to oranges, in this picture here, I'm going to say 2 apples compared to 3 oranges. And I'm going to say apples first because it corresponds with the first word in the sentence, the apples to oranges. So I'm going to say 2 first because there's 2 apples. Okay? So we can write ratios in several different ways. For example, if we wanted to write the number of the number of red to white squares, we can say 3 to 1 and actually write the word 2. Or we can put 3 to 1 signified by this double dots here. Or I can say 3 to 1 with a divide sign, and usually you'll see it written as a numerator and denominator. Okay? So again, with a ratio, we're making a comparison. So if we look at the aliens here, we're going to see um, the ratio of green aliens to purple aliens is 3 to 4. Okay? And the reason we say 3 first and not 4 to 3 is because it states the ratio of green aliens to purple. So my green aliens, there's 1, 2, 3. Purple aliens, there's 1, 2, 3, 4. So the ratio is 3 to 4. If I said, what's the ratio of purple aliens to green aliens, you would say the ratio is 4 to 3. But that's not the case in this problem. All right, so we can also make a ratio of the whole, okay? So the ratio of green aliens to the total aliens. So out of all of the aliens, which is 4 plus 3 is 7, how many are green? Well, the ratio of green to whole is 3 to 7, which is the total number of aliens, okay? And the ratio of purple aliens to total is 4 to 7, okay? Um, so again, we can write ratios in 3 different ways. The same as before, by writing the word 2 with the double dots, or written as a fraction, the numerator over the denominator. So let's just look at a couple more comparisons here. So if we were comparing red to green triangles, we would say 1 to 2. And we would say 1 first because it asks for red to green. Or if I said, what's the green to red ratio, you would say 2 to 1. Again, we can reference it to part of a whole. So if I said, what is the red to whole ratio? If I said, what's the ratio of red triangles to total triangles, you would say 1 to 3. Or green to total, you would say 2 to 3. And backwards, we could say whole to red. So the whole number of triangles is 3, and the total number of red triangles is 1. And the whole to green ratio is 3 triangles to 2 green triangles. If we were to compare octagon to all shapes, we would say, well, there's one octagon here. Octagon's an 8-sided figure. So 1 out of 8 gives us the total, okay, or a 1 to 8 ratio. Compare all shapes to trapezoid. Well, it would be 8 to 1. There's one trapezoid here. And of course, we can write it the 3 different ways. Pentagons to hexagons. Now we're just comparing 2 different ones, not comparing to the whole at all. So the pentagon has 5 sides, so that's this guy, so there's 2. And how many hexagons is there? Well, there's 3. 1, 2, 3, the 6-sided figures. So again, pentagons to hexagons is going to be 2 to 3. If it asks for hexagons to pentagons, we would say 3 to 2. Okay. Now, give each ratio in 3 forms. Again, if I was looking at 8 roses out of 24 flowers, we could write it in the 3 different forms. Okay, I think I've done enough on that now. So 3 dogs out of 12 animals. Again, the 3 different ways in which we can write it. So a ratio in fraction form. So we can express this in its simplest form by dividing both the numerator and denominator by a common factor. Okay, so we can look at something like 8 over 24. I'm not sure if you can see the bottom of this in your screen or not. Let's just adjust this. Hopefully you can see it now. Um, so 8 over 24. If I say, what's my greatest common factor here? Well, 8 is the biggest number that will go into 8 and also 24. So if I divide each by 8, I'm going to get an equivalent fraction or equivalent ratio. Okay, same thing here. I can say 3 out of 12. If I divide that by its greatest common factor, 3, it's the same as a quarter, or 1 over 4. These are equivalent fractions. They mean the same thing. And we'll talk a little bit about that now. So as you can see, if these were chocolate bars, okay, um, and if I ate the top piece of 3 pieces and the top 2 pieces out of 6, if I eat the top 3 pieces out of 9, it's all going to be the same. Okay, I'm still going to have the red left over. This is my chocolate that's left over. So as you can see, 2 out of 3 pieces is the same as 4 out of 6 is the same as 6 out of 9 pieces. So these are referred to equivalent fractions. This is also interchangeably with equivalent ratios. Okay. Now, if you want to make an equivalent fraction, it's actually really easy to do. Okay. So all we do is multiply our fraction by the same number. Okay, the top and bottom. So the numerator and the denominator get multiplied by the same number. And we're going to get a new fraction. It's going to mean the exact same thing as the other one, just like in the picture back here. And we're not going to change the value of the fraction, okay? We're simply multiplying by 1, a fraction that has an equivalent to 1. And I'll explain a little bit about that. So whenever you multiply a number by 1, what do you get? Well, you get that exact same number. 5 times 1 is 5. 37 times 1 is 37. A million times 1 is a million. It doesn't change, right? All of these are fractions, okay, on this page. So a 2 over 2, if you went in on your calculator and you punched in 2 divided by 2, what are you going to get? Well, you're going to get 1. So all of these fractions here that have the numerator and the denominator the same are just equivalent to 1. Okay? They mean the same thing. 33 over 33 means 1. So if you multiply something by 33 over 33, it's not going to change, is it? Because 33 over 33 is the same as 1. Okay? So when we multiply by 1, we're going to get an equivalent fraction. Okay? It's going to mean the exact same thing. For example, if we look at this, I look at this and I think of like a Kit Kat bar, chocolate bar. I don't know why I'm talking about chocolate all the time, but okay. I must be hungry. 3 out of 5. Here, if I pick this square up and lay it on top of this one, it's going to be the same amount, isn't it? Okay. Uh, in this chocolate bar here, I've got 1, 2, 3, 4, 5 pieces by 1, 2, 3, 4. So there's 20 pieces here, and I've got 1, 2, 3, 4 times 3 is 12. Okay. So 3 out of 5 pieces is the same as 12 over 20. Now I got that by multiplying by 4, the numerator and the denominator by 4, as you can see I did up here. So as long as I multiply the top and the bottom by the same numbers, I'm going to get an equivalent fraction. That's it. Okay. Um, in this case, 3 times 4 is 12, 5 times 4 is 20. I could have picked the number 5 if I wanted to and said 3 times 5 is 15 and 5 times 5 is 25. Well, 15 over 25 means the same as 12 over 20, means the same as 3 over 4. Okay? It all represents the same thing. So, if you were going to make an equivalent fraction here for 2 over 3, you can multiply the numerator and the denominator by the same number, and we're going to get an equivalent fraction. Okay? So, I worked this out and I got 6 over 9. How did I get that? Well, I was given the 9. So we multiplied the numerator and the denominator actually by 3, because I said 3 times what number gives me 9 times 3. If I multiply the bottom by 3, I must multiply the top by 3. Okay? And then I'm going to get an equivalent fraction. 2 over 3 is the same as 6 over 9. Look at this example. 9 times what number will give me 36? Okay, so you can use your calculator, you can use your multiplication charts, you can use your fingers and your hands, whatever gets you the right answer, and you'll find that 9 times 4, there we go, will give you 36. If we multiply the top by 4, we're going to get 16. Okay, now we can also go the other way. To get an equivalent fraction, we don't always have to multiply and go up to get an equivalent fraction. If we're given a big number that's a fraction, um, we can say we can just divide by a number that'll equal 1. So uh, again, we just pick a number that will divide in to 72. Okay, so I solved this to be 45. Well, how did I get that? I looked at this problem and said 72 divided by what number gives me 8? And I figured that number to be 9. Okay, so to get this, I say, well, 9 times 5 will give me 45. So that must mean I divided by 9 to get this. Okay, and that about does it for equivalent ratios and ratios in general. Please come see me if you need extra help, and good luck on your quiz.